The work performed by insulators can take us just about anywhere, but some changes in the nuclear industry are creating exciting new opportunities in those nuclear facilities. The safe operation of a nuclear facility is the #1 priority. A major component of all facility safety protocols includes an annual shutdown for a rigorous inspection and maintenance program. How long the facility is down, not producing product and therefore not generating revenue, depends on how fast the inspection and related maintenance takes. And as the facility ages, the number of required inspections increases. Throughout a nuclear facility, the need exists to safely and quickly remove insulation in order to inspect and, in some situations, replace critical equipment, which is why reflective metal insulation, or RMI, is becoming an industry standard. Many of our locals across the US and Canada are not currently doing RMI work, and similarly, many are not including RMI in its training programs. Learning these skills needed to apply and modify this unique material can open the door to a wealth of specialized employment opportunities, which is why the International Association of Heat and Frost Insulators and Allied Workers has produced this video. We'll introduce you to reflective metal insulation, explain some of the unique requirements for installing the product, and then demonstrate a few common modifications a trained insulator would be expected to perform. Reflective metal insulation is an engineered insulation system of individually designed segments that are almost always constructed of non-corrosive stainless steel sheet metal. The reusable modular insulation system is the key to allowing nuclear plants' facilities to reduce time for inspection and maintenance. Once in place, the system requires fewer plant personnel to complete the inspection process. While expensive, the process is actually cost-effective when the initial expenditure is calculated to be offset by a lifetime of operating savings. Reflective metal insulation uses a heavier gauge outer shell to hold its shape. Inside the shell are numerous layers of lighter gauge foils, carefully spaced and separated, or dimpled, inside each segment. Each segment, or capsule, is then carefully designed to prevent gaps and fit tightly with other segments and mating pieces. The RMI you see here is a specific manufacturer's product. Other manufacturers produce something similar, but it might have slight differences, such as how segments are assembled or latched together. When hired for an install, trained insulators are expected to be able to install and modify and individually design each section to the geometry of the plant. The work is frequently done on-site in state-of-the-art trailers designed and equipped specifically for this type of work. Much of the modification work centers on items in the way or intersecting, adding a latch system and identification coding to each individual segment of the insulation. So let's take a look at a typical RMI cassette. For a traditional straight pipe, 2 half shells of RMI are used, but a latching system to fasten the 2 pieces together must be added. Here, the suitcase latch system is quickly bent to better match the contour of the cassette. With the latches properly bent to the contour of the cassette, marks are made indicating where the stainless steel studs will go to hold the latching system and handles in place. A stud gun welder is used for this step. Washers are then added, followed by a hex locking nut to hold the latches and handles onto the half shells. Each latch has an adjustable connector to ensure a secure fit. The same process is repeated on the other end of the cassette. Depending on the number of connecting points for the piece, additional latches may be needed at other locations on the shell. Next, an end face must be fitted. Insulators usually call this an end cap, and it is similar in use. Like the outer face, an end face is thicker stainless steel than the inner layers. To attach the end face, a fabricated piece of stainless steel must be spot welded to the outer face. This provides a welding area to attach the pieces together. A similar piece is spot welded to the end face to provide the needed welding area. Depending on the size and shape, the insulator can use a handheld spot welder or the larger rock arm spot welder. Once together, edges are smoothed with an angle grinder to allow for an easy fit during installation. Now that you've seen how a basic RMI cassette is prepared for installation, let's take a quick look at 2 common modifications. The first involves a situation where a small cutout is required to accommodate another pipe crossing at 90 degrees nearby. Measurements are transferred onto the cassette to show the area that needs to be removed. A handheld metal shear quickly cuts out the designated area of both the outer face and the end face. Metal shears and a metal file are then used to cleanly remove the thin inner layers of insulating foil. Once the foil is removed, a process similar to installing the end face is repeated, first cutting the thicker fortification pieces to provide a welding area, followed by a new custom-fitted end face, spot welded and then grinded smooth. Our second modification begins again with a basic capsule cassette piece, only this time the pipe needing insulation runs too close to a wall and there's not enough space for a full shell. This modification will require a cut running the length of the backside of the capsule cassette, but many of the same techniques are repeated. The insulator again starts by taking measurements to determine the amount of material that needs to be removed. Turning at about 4,000 RPM, the handheld metal shear can cut between 5 and 8 feet per minute, making this cut a relatively easy process. Once the cut outer shell is removed, only the minimum number of foil layers are removed to best maintain the insulating ability of the RMI cassette. After smoothing out the edges, the larger pieces of the thick stainless steel are fitted, followed by spot welds along the length of the cutting area. And the final step involves cutting a new flat outer face, again grinded smooth to ensure an easy fit to the adjacent cassette. A final step not seen in this demonstration would be the addition of stainless steel identification tags. The identification system will be unique to each facility, but it usually includes a series of numbers and/or color coding to aid in placement of each capsule throughout the entire system. Each piece must be marked with an ID tag before installation. You've seen two simple modifications, but work like this by trained insulators could last weeks. Remember, not every piece of reflective metal insulation in a nuclear facility requires modification, but these basic skills are necessary for a professional installation. The International Association of Heat and Frost Insulators and Allied Workers believes there is tremendous potential and opportunity in this field, making it worthy of further study. We hope this brief introductory provides you a brief explanation of this material and the motivation to pursue it further. The International Association of Heat and Frost Insulators and Allied Workers would like to thank the following companies for their help in making this video.